reaching out to already to billions of light years. So why do we know the distance? That's interesting now. I told you that it's not just the telescope, it's modeling our observation. And that's what we teach here in the planetarium, and what we're trying to make people understand, that each observation needs to be interpreted in the framework of a model, of a grid we throw at the universe, and we catch the observation, and we place them in the model. Why do we know the distance? Well, that's the model that redshift means distance, and we place, according to redshift, these quasars at the appropriate distance. And it's a good model because the predictions have been quite fulfilled by that model. So each model we use is good as long as the predictions are good. But it's observation in different wavelengths, it's data sets that astronomers use. And let's go further out, and we fly around those data. As a matter of fact, we can display them even in stereoscopic here in 3D with glasses. But let's go further out here with our data set. Mapping the universe, the structure of the universe is interesting because the telescopes are not just a spaceship for our eyes looking into deep space. Telescopes are time machines where we can travel back and tracing the structures and the evolution of the universe back to the very beginning, to primordial times. So let's go further out from the center of view. So you see, we have the feeling we are at the center of the universe, but it's just our point of observation. And we end up at a wall surrounding us. This is the cosmic microwave background. And that's a strange tapestry. That's the oldest signal we can look at. We look out to 13 billion light years, so back in time 13 billion years. So to the fiery epoch where the universe was hotter than the surface of the sun. And it was opaque, so we cannot look through that part. We cannot look deeper. And so we see we fly through space and time. So telescope help us not just to get a spatial grid of the universe, but also to get the evolution of the universe. And planetariums these days allow us, are like the machines are simulators of the evolution of the universe. And even astronomers like Brent Tully in Hawaii with my dear colleague Sean Latch and others, they work together to visualize those data on big domes, on big planetarium domes. And we do that here in Hamburg now in real time. And I fly you back, and you see we now have a different answer on the question, where in space and time are we? We understand that we are quite a tiny speck of dust, but here on Earth, but we are part of the grandest story ever. That's the story of the universe. And we came a long way since Galileo first looked through the telescope, because we now have this international teamwork in place. We have lots of astronomers working together around the globe. This is the best thing, and it's great to see the folks in South Africa, in Northern Ireland, and hopefully also then soon the folks in Philadelphia, how we all share the stars around the world and use them as a framework for our culture, for our cultural activity, for understanding our place in this biggest story ever. And we fly back into our galaxy, and I take you back home, and we see this is now really fascinating. The universe is fascinating, and telescopes plus the interpretation and the display systems nowadays work hand in hand to make this magic, make this really a magical thing here, our galaxy, our city of stars. So I think I salute the folks in Philadelphia. I salute Galileo, who started all that, and we fly back through the other worlds surrounding neighboring stars. We fly back to our planet Earth. Well, we have to first fly to our sun, a tiny little star, which we will quickly end up with. So in 3D we can understand the universe, because everything needs to be displayed that way to really understand it. And I think planetariums and science centers especially are in a very important role here. They have a very important role to fulfill, to communicate those this fascinating universe here to the people of all ages, especially to the younger people, to spark the energy, and to spark their interest into science and engineering. You see, we're flying back through our solar system, and we're approaching Earth, and I hope I can take you down to Hamburg here if I have a minute still. But let's see, the Earth, there's the orbit of the moon around the Earth. And by the way, we can depict, also show data of our immediate surrounding, data gathered by satellite, especially NASA satellites, about the magnetosphere. You see the Earth in the magnetosphere, and it's like a big comet, the Earth, and we are shielded from the harshness of the environment here. The small Earth surrounded by the magnetic field, and we fly around, we fly into the magnetic field, which was necessary, which was helping us to survive here on Earth. And we approach, here is Africa, down there is South Africa. Let's fly around further north down to Hamburg. Hopefully I can manage to be back in our harbor city of Hamburg. And we move closer and closer. And you see the data of the magnetosphere and of the solar activity can be displayed. We do that here in Hamburg together with friends and folks in Göttingen and at the Goddard Space Flight Center with real data, showing real data of the missions, of the stereo missions. So we are part of a much larger environment here on Earth. It's a fragile planet, Earth, and we are going down here to Hamburg. You see the river Elbe, and I told you it's a harbor city, and we have a high-resolution picture of our harbor region here, and I think I managed to fly you to the harbor of Hamburg to close my presentation somehow. Well, we have the tools now to show the beauty of the universe and to show the fascination of the universe. Here we are back looking at the harbor of Hamburg, and north of that big spot of water there is the planetarium, well, and the upper end of the image now. Well, I hope you all have open minds and open hearts to feel this beauty and this inspiration of the universe, which the virtual observatories around the world, be it the worldwide telescope or tools we use at the planetarium here, they can show us the universe and connect the local observations with the global picture of the universe, with our understanding. The framework that I talked about in the beginning is a bigger one, and we have to make a meaning, make a sense of that. And we have a glimpse of, each glimpse of the starry night together with our model of the universe will make sense in this endeavor. So